Hey, this is Juan Berciaga doing the standard on the ear and how it works. So, kind of want to go by here showing you the pictures of the ear, and you have your cochlea here, just round it up, and then when you unroll it, you have the cochlea, which is a long, sort of a tube-ish. It has it's a long membrane, and we can tell that sound excites the membrane. And when sound waves come in, they excite a specific spot, and the clochlea gets excited. If you get a frequency sound here, and it moves up and down, or you can have a sound here, high pitch here, and then low pitch here. It would just move. And when the clochlea gets excited, the membrane, the it sends nerve pulses to the brain, and the brain interprets that as a specific frequency. And kind of next want to talk about how sounds can be determined by the loudness or quiet, and then convert that into decibels. So here, we have our absolute quiet here, so it's barely noticeable, and the absolute loud, just ridiculously loud, where your ears are bleeding, and it's painful, and we convert that to crickets in class. So we would say that your absolute quiet is equal to one cricket, and then the tolerance pain level here of loudness is equal to 1 trillion, or 10 to the 12th. And we wanted to say what was the halfway point, and some would say it's 500 million. In that case, it's right, but for this thing, it's wrong. We would say that for the halfway point would be 10 to the 6. And then we kind of wanted to know, like, how many crickets would it take for you to hear a change? So if you had one cricket and you add another one, sure, you can hear it. Or if you had 10 crickets and added one more to 11, yeah, you can hear it. But then if you had 1,000 crickets, and you increase by 10%, so that'd be a 1,100, a change of 100 crickets. It wouldn't be so much of a change. It might sound the same, but at the same time, if you had a million crickets and you had the change increase to 10%, so it'd be a million and 100,000, a change of 100,000. That right there, you would notice that there's going to be a large amount of change in sound. So you would have to have a big change before noticing the sound to change. And so we would try to play and keep intensity to play in this. So our absolute loudness for intensity would be 1 watt per meter square, and the lowest would be 110 to the negative 12 watt per meter squared. And we would use our logarithm here to say that you have your 10 to the 0 is your lowest, the 10 to the 6 is high, and then 10 to the 12 is your absolute high. Sorry, 10 to the 6 is your halfway point. And you would convert that into Bell scale, into the Bell scale, which is basically just taking the exponent. So for 10 to the 0, which is in Bell scale, would be 0, 10 to the 6, 6, and then 10 to the 12 is 12. And then you want to change that into Bessey scales. So you would just multiply by 10. Deci means 10. And so 0 times 10 is 0. 6 times 10 is 60. And 12 times 10 is 120. So you would use your intensity, um, what you can hear, and convert that to crickets, and then you would convert that to bells, and then you would convert that into decibels. So the intensity, so if we had intensity of 10 to the negative 5 watts per meter squared, and then change that to crickets. So you would have 10 to the negative 5 plus 12 because they're absolute limit. And so that would be 10 to the 7th. And then you convert that to bells. So you just take the exponent. So it'd just be 7 here. And then you will multiply that by 10 to change it to decibels. So it would be 70. 10 times 7 is 70. And if you wanted to convert decibels into your intensity, so let's use another number. We'll use, uh, let's just use 9. So 90, I'm sorry, we have decibel of 90, and we change that to bells, so we divide that by 10, so we get 9. And then we would um, subtract 12 from that, so we would get 3. Sorry about that. So we have 10 to the negative third in our for the intensity. That's what I meant. Yeah. So here is the example of how the years work, the colloquia, and then how to turn our intensity into decibels by using crickets and then the bell and intensity to turn it all into decibel. Thanks.